Silver is widely discussed as if it were produced like iron ore or coal. Demand rises, price rises, miners dig more, supply increases. The physical reality is different because most silver is not mined as the main product of a silver mine. For decades, industry production breakdowns have consistently shown that roughly 2/3 to 3/4 of newly mined silver is produced as a byproduct of mining other metals, especially lead and zinc, copper, and to a smaller extent, gold. The commonly cited shorthand is that about 70% of mine supply is byproduct silver. That single fact changes the entire supply story because a byproduct does not respond primarily to the price signal of the byproduct. It responds to the economics of the host metal, the geology of the ore body, the throughput of the mill, and the recovery circuits installed to capture what would otherwise end up in tailings. A primary silver mine decides whether to expand largely on silver prices, silver grades, and the local cost structure. A copper mine decides whether to expand on copper prices, copper grades, energy costs, acid costs, water constraints, and the capital required for a larger concentrator. If the copper mine happens to contain silver in the ore, the silver output rises or falls with copper mining activity, even if silver demand is moving in the opposite direction. The same logic applies to zinc and lead operations, where silver can be embedded in sulfide concentrates and recovered downstream. This is why the question, why can't the world just mine more silver, is often answered not in the silver market itself, but in the base metals market that produces most of the world's silver as an incidental stream. The mechanics start with geology. Silver occurs in primary silver deposits, but it also occurs widely in polymetallic sulfide systems, epithermal veins, and porphyry systems that are mined primarily for copper, lead, zinc, or gold. In many of these deposits, silver is not present as native silver bars waiting to be collected. It is dispersed in mineral grains and recovered through flotation and refining steps designed around the main payable metal. At a copper mine, the core value is copper in the concentrate, because copper revenue typically dominates the cash flow. Silver, if present, may be payable as a precious metal credit, but it is usually a smaller fraction of revenue. That means silver does not control the mine plan. The mine plan is controlled by copper tonnage, copper grade, strip ratio, metallurgical recovery, and the capacity of the crushing, grinding, and flotation circuits. If copper grades decline, the mine may process more ore to maintain copper output, but that is constrained by mill capacity, power, and water. If copper grades decline and costs rise faster than copper prices, the mine may slow expansion or defer new pits, and the silver byproduct declines with it. At a lead-zinc operation, a similar dynamic holds. Many of the world's largest zinc and lead deposits are polymetallic. They produce concentrates that are sold to smelters, and the silver may be recovered in the smelting and refining chain and paid back to the miner under concentrate terms. Again, the decision to mine more is anchored in zinc and lead market fundamentals. When zinc prices are weak, or when smelter treatment charges and concentrate terms shift against miners, marginal operations reduce output, and the silver that would have been recovered from those concentrates does not appear. This is the first structural constraint. Most silver supply is tied to metals whose markets and investment cycles are separate from silver. The second constraint is time. New mining capacity is not activated like a factory shift. Major mine expansions and new mines require years of exploration, resource definition drilling, feasibility studies, financing, permitting, community engagement, construction, commissioning, and then ramp up to nameplate capacity. Even when a deposit is already known, converting it into additional metal output depends on physical infrastructure: pits, underground development, mills, tailings facilities, power lines, roads, water rights, and labor. Silver's byproduct status adds another layer. Even if the world wanted more silver specifically, the projects most likely to deliver more silver quickly are not necessarily silver projects. They are copper projects and zinc projects that carry silver in the ore. That means silver supply is indirectly constrained by the project pipelines and capital cycles of the base metals industry. Copper is a capital-intensive business dominated by large-scale mines with enormous concentrators and long-lived ore bodies. Zinc and lead are heavily influenced by concentrate market balances, smelting capacity, and the economics of underground mining in many districts. If investment slows in copper and zinc, silver supply growth slows mechanically, because most silver is flowing through those channels. The third constraint is that byproduct silver is not automatically recoverable. The amount of silver produced from a given ton of ore depends on metallurgy and processing choices. If a base metal concentrator is not optimized to capture silver, or if silver is locked in minerals that do not float well under the plant's operating conditions, the recoverable silver may be lower than the silver contained in the rock. Improving recoveries often requires capital spending on circuits, reagents, and in some cases downstream refining arrangements. Those investments are justified when the total incremental revenue exceeds the cost, and that calculation is made in the context of the host mine's priorities. In practice, silver revenue can be meaningful as a credit, but it still competes for capital with debottlenecking projects that raise copper recovery, increase throughput, or reduce unit costs. When copper margins are under pressure, capital is often allocated to sustaining and compliance projects first, because mines must maintain safe operations and meet environmental permits to keep operating at all. That means silver recovery upgrades can be delayed, and the silver that exists in the ore may not translate into additional market supply. The fourth constraint is that global silver production is geographically and corporately distributed in a way that reflects base metals geography. Countries that are major silver producers are often also major base metals producers, because silver output is embedded in polymetallic mining districts. That is one reason why many top silver producers lists include countries with large copper, zinc, and lead sectors. It is also why many of the companies that influence silver supply are not silver companies. They are diversified miners and base metal operators whose primary exposure is copper, zinc, lead, and often gold. Their production decisions respond to those markets. This matters for how deficits propagate. If the zinc market tightens or loosens, the silver market feels it through byproduct flows. If copper production is disrupted by operational issues, declining grades, energy shortages, strikes, water constraints, or slower project approvals, the silver market feels it without any change in silver-specific mining intentions. The phrase deficit in these metals hits silver is best understood as a mechanical linkage. When base metal mining declines, byproduct silver declines as a secondary effect. The fifth constraint is that much of the world's base metal capacity is already operating near physical limits that are not solved by higher prices alone. Ore grades have trended lower in many mature mining districts, which means more rock must be moved and processed to produce the same amount of metal. Moving and grinding more rock requires more diesel, more electricity, more explosives, more water, larger tailings facilities, and more maintenance. These are not abstract inputs. They are hard constraints in permitting and in operating costs. The energy intensity of grinding is a central cost driver in concentrator operations, and water availability is a binding constraint in many large copper regions. When those constraints tighten, mines can't simply scale output linearly. If a copper mine cannot secure additional water rights, it cannot expand the mill even if copper prices rise. If a tailings facility reaches design capacity, expansion requires new engineering, approvals, and construction, often measured in years. If grid power is limited, mines must build generation or transmission, again a long timeline. Because byproduct silver is tied to throughput, these constraints on base metal throughput become constraints on silver supply. The sixth constraint is the way mining economics allocates silver. In many mines, silver functions as a credit that reduces the net cash cost of producing the main metal. That makes silver valuable to the operator, but it does not necessarily make silver the driver of expansion decisions. If a copper mine produces copper, molybdenum, gold, and silver, the mine plan is still a copper plan. Silver helps the margin, but it rarely defines the investment thesis. This is why the idea of responding to silver demand with silver supply is structurally muted. If silver demand rises because of industrial uses, electrification, or electronics, the mine supply response depends heavily on whether copper and zinc mines also expand, and whether their ore grades and recoveries support higher precious metal byproduct output. Without that, silver must be balanced through other channels: above-ground stocks, recycling flows, inventory drawdowns in commercial supply chains, and substitution in industrial processes where technically feasible. Those channels exist, but they behave differently than a typical commodity where mine output is the dominant adjustable lever. The seventh constraint is that primary silver mines, while important, are not the majority of supply. Primary silver operations exist, but many of them are in districts where silver grades are declining, costs are rising, or the ore is co-produced with other metals anyway. Even when a company calls itself a primary silver producer, its actual revenue mix often includes meaningful gold, lead, or zinc. This matters because it limits how much pure silver supply can be ramped independently. A new primary silver project must compete for capital, permitting attention and operating talent in the same global mining labor market, and it must contend with the same issues: rising costs for steel, fuel, explosives, and skilled labor, plus stricter environmental requirements around tailings and water management. It also faces market constraints in the refining chain. Silver produced as concentrate or doré must be refined. Refining is a separate industrial capacity, and while silver refining is broadly available, bottlenecks can arise when concentrates carry penalties, when smelter terms shift, or when logistics are disrupted. When silver is produced via lead-zinc concentrates, it depends on smelting and refining economics and capacity, not only on mine output. If smelter availability tightens, or if treatment charges rise to levels that squeeze miners, The incentive to push marginal ore can weaken. Again, silver supply is pulled along by the base metal chain. The eighth constraint is that the base metal markets themselves are cyclical and often driven by construction, infrastructure, and industrial growth, which can diverge from silver's own demand drivers. Copper demand is strongly linked to construction, power grids, industrial equipment, and now electrification hardware. Zinc demand is heavily tied to galvanizing steel for construction and manufacturing. These sectors move with global growth cycles, interest rates, and government infrastructure spending. Silver demand has a large industrial component too, but it also has unique components tied to electronics, photovoltaics, and investment demand. When global growth slows, copper and zinc mines may cut capital expenditures and delay expansions. If silver industrial demand remains strong in that same period, the silver market can face a mismatch because the host metal production that supplies most silver is decelerating. The mismatch does not require any silver shortage narrative. It arises from production structure. Byproduct metals are hostage to the production decisions of the main metals. This is the core reason you cannot simply dig more silver in response to a silver-specific supply concern. The ninth constraint is operational disruptions. Base metal mines face risks that are independent of silver. A strike at a large copper mine affects copper first, but it also removes the silver and gold byproducts embedded in the copper concentrate stream. Weather disruptions, power failures, transport constraints, or regulatory suspensions have the same effect. A shutdown at a zinc mine reduces zinc output, but it also removes the silver that would have been recovered from those concentrates. For the silver market, these disruptions can look like sudden supply squeezes, but the root cause is a disruption in a different metal's supply chain. This is why silver can behave like a precious metal in investor narratives, while being constrained like an industrial byproduct in physical supply. The 10th constraint is grade and recovery arithmetic. If 70% of silver is byproduct, the incremental silver supply from more mining depends on the silver content of the ore being mined for copper and zinc. Not all copper ore contains meaningful silver. Not all zinc ore carries high silver credits. The global base metal pipeline includes deposits with very different byproduct profiles. That means even a boom in copper investment does not guarantee a proportional boom in silver. A porphyry copper deposit might have low silver and high molybdenum, while a polymetallic deposit might have meaningful silver credits. The silver market is therefore sensitive not just to the amount of base metal mining, but to the specific mix of deposits being developed and the metallurgy chosen. That mix changes slowly because mines are long-lived assets planned years in advance. The consequence is that the silver supply curve is less elastic than many assume. Elasticity is not a theory here. It is a description of what can change quickly. When most silver comes from someone else's mine plan, silver cannot rapidly increase supply without a coincident expansion in those host mines, or a wave of recovery and throughput investments that must clear technical and regulatory constraints. Put differently, if global copper output flattens due to grade decline or delayed projects, and if zinc output flattens due to closures or weaker investment, silver output faces headwinds even if the silver price rises. The price signal is real, but it is filtered through the host metal structure. The history of commodity cycles offers repeated examples of this filtering effect. During periods of weak base metal prices, mines high grade, reduce development, and delay expansions. Byproduct streams tighten. When base metal prices strengthen, output expands, but with long lead times. The byproduct stream expands later, not immediately. That lag is one reason silver's physical market can tighten in ways that are not explained by silver mining headlines alone. The final piece is to connect the structure to the phrase mining at the limit. In practice, at the limit means that the marginal ton of additional ore is more expensive and harder to permit than the previous ton, because it requires more stripping, more energy, more water, larger waste volumes, and more complex community and environmental approvals. Base metal mines that supply most silver are already navigating those limits. When those limits bind, byproduct silver cannot simply be scaled by will. The silver is there in the rock, but the decision to bring that rock to the surface and process it depends on copper and zinc economics, not on silver alone. The conclusion is not a prediction about prices or a claim that shortages are inevitable. The conclusion is a production structure. When a commodity is mostly a byproduct, its supply is governed by the main commodities that carry it. In silver's case, copper and zinc are not just related markets. They are the upstream engines that determine whether the majority of new silver arrives at all.